The explorers of the past discovered new lands and founded colonies, many of which still exist today. Elon Musk has the same spirit of exploration, but his target is literally out of this world. He wants to form a settlement on an entirely different planet, Mars. One problem he has is that going to Mars will take you 5 months at the shortest, which to Musk is just too long. However, he has found an ingenious way to cut the trip to just 100 days or even less. What is this method and how does it work? Join us as we dive into SpaceX's Nuclear Starship that is finally happening. If you are planning a trip to Mars, you would better start with how you will cover the vast space between Earth and the Red Planet. Even if you choose the best time to take off, which comes around once in a while when the two planets align the most, you will spend the next 5 months in transit as you cover millions of miles. Space is massive, and anywhere you are going is far.
3, 2, 1.
Humanity has been making do with large fuel-burning rockets when we head for space, but it is limited where we can go because we have to take into consideration the amount of energy required for the trips and the time it will take. SpaceX is working on the Starship to take people to Mars, but while the current Starship can carry lots of cargo, it will not cut down the travel time significantly. As Musk is aware, you don't want to spend 5 months between Earth and Mars. This is because there are so many risks with that. Astronauts on a trip to Mars would be exposed to very high levels of radiation, which can cause serious long-term health problems such as cancer and sterility. As explorers going to populate a new territory, Musk wants them to arrive as healthy and fertile as possible. Radiation shielding can help, but it's extremely heavy, and the longer the mission, the more shielding is needed. A better way to reduce radiation exposure is to simply get where you are going quicker. Also, the more time you spend in transit, the higher the chance of something going wrong. You could run out of fuel, for example, or a component breaks down. You also want to think of the problems with confining 100 people to a space as small as the interior of a spacecraft. Emotions might flare and cause conflicts, jeopardizing the mission. And deep space is the last place you want something to go wrong because you are entirely on your own. So Elon Musk basically needs to find the shortest way to move people to Mars. Even when the Starship is not transporting humans to Mars, it makes sense for space trips to be shorter. For example, during space exploration for science, it is important to get data from unmanned missions as soon as possible. Consider that it took Voyager 2 12 years just to reach Neptune, where it snapped some incredible photos as it flew by. If Voyager 2 had a faster propulsion system, astronomers could have had those photos and the information they contained years earlier, moving our knowledge of the universe forward faster. Musk has indicated in the past that he is considering different options for powering spacecraft. For instance, he has tweeted about how nuclear-powered rockets would be a great area of research for NASA. He has good reasons for this because nuclear systems are faster. But why is a nuclear-powered Starship faster? To answer this question, let's look at the basics of how rockets work in space currently. Once you manage to escape the Earth's gravitational pull, you have 3 things to worry about. Number 1 is thrust, which is how fast a system can accelerate a ship. Number 2 is mass efficiency, which is how much thrust a system can produce for a given amount of fuel. And lastly, energy density is how much energy a given amount of fuel can produce. The most common propulsion systems in use are chemical propulsion, regular fuel-burning rockets, and solar-powered electric propulsion systems. While chemical propulsion systems provide a lot of thrust, chemical rockets aren't particularly efficient. This is because rocket fuel isn't that energy dense. For instance, the Saturn V rocket that took astronauts to the moon produced 35 million newtons of force at liftoff and carried 950,000 gallons of fuel. While most of the fuel was used in getting the rocket into orbit, the limitation is that it takes a lot of heavy fuel to get anywhere. The other option uses solar panels to generate thrust using electricity. The most common way to do this is to use an electric field to accelerate ions, such as in the Hall thruster. These devices are commonly used to power satellites and can have more than 5 times higher mass efficiency than chemical systems, but they produce much less thrust, like about 3 newtons, or only enough to accelerate a car from 0 to 60 miles per hour in about 2.5 hours. You don't want to head for Mars in such a slow spacecraft. That is even before you think of the number of solar panels required to power the Starship, which will be simply ridiculous. Besides, the energy source, that is the sun, might be infinite but becomes less useful the farther away from the sun the Starship gets. However, a nuclear-powered Starship is more promising because nuclear energy systems offer incredible energy density. The uranium fuel used in nuclear reactors has an energy density that is 4 million times higher than hydrazine, a typical chemical rocket propellant. The current Starship does not use hydrazine, but the fuel still isn't anywhere near as efficient as uranium fuel. And think of it this way, it is much easier to get a small amount of uranium to space than hundreds of thousands of gallons of fuel. Before we talk about the different options for Musk's nuclear-powered Starship, there is one question that might be on your mind. Is a nuclear-powered Starship safe? Many people's idea of anything nuclear is a disaster waiting to happen or harmful radiation that could make humans very sick. Let's look at the safety of the riders in the Starship first. The risk of radiation would be mitigated through the rocket's design. Liquid propellants, yes, the Starship will still carry propellants for backup stored between the engine and the crew area, block out radioactive particles, acting as a good radiation shield. Apart from that, the distance between the crew and reactor also provides a buffer, as the design would place the living quarters at the other end of the rocket, the reactor. So what about the safety of people outside the Starship? Musk has already thought of that. In another tweet, he said the nuclear reactor on board the spacecraft will only kick in when it's cleared the Earth's orbit. This shows Musk is proceeding with lots of caution. This also means the Starship will still be launched by the Super Heavy, powered by chemical propellants, but the nuclear reactor will fire up after the two stages separate. Once in orbit, the nuclear reactor can do little harm as blasts and thermal radiation cannot move through a vacuum. If disaster struck and the rocket's reactor broke up, the pieces would not even land on Earth or any other planet for tens of thousands of years. By that time, the radioactive substance would have naturally decayed to the point where it wasn't hazardous anymore. So a nuclear-powered Starship is safe for everybody. Now let's talk about the configurations of the nuclear system in the Starship. Musk could use two main types of nuclear systems for the Starship. The first is called nuclear thermal propulsion. These systems are very powerful and moderately efficient. They use a small nuclear fission reactor, similar to those powering nuclear submarines, to heat a gas like hydrogen. The gas is then accelerated through a rocket nozzle to provide thrust. A Starship going to Mars on nuclear thermal propulsion would be 20% to 25% faster than a trip on a chemical-powered rocket. Nuclear thermal propulsion systems are more than twice as efficient as chemical propulsion systems, meaning they generate twice as much thrust using the same amount of propellant mass and can deliver 100,000 newtons of thrust. This is enough force to get a car from 0 to 60 miles per hour in about a quarter of a second. The second nuclear-based rocket system is called nuclear electric propulsion. The idea is to use a high-power fission reactor to generate electricity that would then power an electric propulsion system like a Hall thruster. This would be very efficient, about 3 times better than a nuclear thermal propulsion system. Since the nuclear reactor could create a lot of power, the Starship could carry many electric thrusters that could be operated simultaneously to generate a good amount of thrust. Nuclear electric systems would be the best choice for the extremely long-range missions that Musk plans for the Starship because they have very high efficiency and can give relatively high thrust. Let's hear what you think of Musk's nuclear-powered Starship in the comments section below.